Splunk has an excellent statistical command set, but it has no way of applying set operations to fields. So there's commands like diff, which can be applied to a subsearch, but if we want to compare the values of fields across a data set, there's no way of actually doing that. And we can mimic that behavior in some respects by using the statistical commands in Splunk. But this is really unfortunate because set operations have enormous potential for detecting anomalies based upon how many elements, in this case fields, are distinct from the fields in every other event. And this is particularly relevant for security use cases. So previously I wrote an app called the Third Man app for Splunk, and it did just this. So it was looking for misappropriated credentials by essentially shoehorning statistical commands into applying set operations. And so since then I've gone about actually writing a custom search command that can do this natively and can do it better and more efficiently. So there's no better way to explain this than to actually have a look. So we have a trivial data set here in this lookup. It has 3 fields in it, and if we think about this as mimicking a real data set, we simply want to find which event of the 4 here is distinct from the others. So by and large, for example, if we take a real use case of examining successful user authentication behavior, by and large they're going to have a very predictable pattern of authentication. So the same is true here. Most of these events are quite similar to one another, but there's one event which is particularly distinct. So with this new command, we can find that. Distinct fields, and then we just provide the field list. So field 1, field 2, and field 3. So this is going to give us a new field called distinctfields, and it will have in it the names of the fields which are distinct from the rest of the data set. So in this instance, we can see that field 3 has a unique value relative to the rest of the data set, a value of G. So that's good. In the case of this event here, it has 2 distinct fields, field 2 and field 3. So field 2 has a value of D, which is unique, and field 3 has a value of F, which is also unique. So why or how this could be useful in a security context is if we then pipe that to an eval and we say count equals multi-value count of distinct fields. So now we have a count field, and this is very, very similar to what was done with the Third Man app, but we've done it in 2 commands. Essentially now we can see that this first event here is highly predictable, so there's nothing anomalous about it. This third event here is equally quite common. This one here has a count of 1, so it's slightly unusual, but it's not highly unusual. But this event here has a count of 2. So for example, we could put in a threshold here where count is greater than 1, and we've detected our anomaly. So yeah, that's pretty much an overview of this very, very raw new search command that I've been working on. Hopefully it's going to become more refined in the future, and I'll do a better video that has a real data set. But I hope that you can see the potential of this. It is a completely different way of looking at anomaly detection, particularly for security use cases.